Today we're going to look at tables of linear functions, and our goal is to be able to write an equation when we're given a table. The equation form that we're going to continue to use looks like this. We've got y equals the rate of change x plus whatever the zeroth term is. And remember, yesterday we said the zero term is something that we also consider to be our initial value or our beginning value. And also yesterday we looked at rate of change. We said rate of change is the change in y over the change in x. So remember that little triangle is just the symbol for, is the Greek letter delta, and it's the symbol that means change. And another reminder for you, when our rate of change is positive, that means our values are increasing. When our rate of change is negative, our values are decreasing. So we've got two tables for you. If you have not printed out the template for this, go ahead and copy this table down. Pause the video if you need to. So we've got this table, and the first question it's going to ask us is, what is the zeroth number? So in a table, when we're looking for the zeroth number, we're looking for the y value that is paired with x when x is 0. So we're looking for really what we want to focus in on is when x is 0, that's going to give us our zeroth term. So that's where I'm looking to find this number. And we describe the zeroth number, our beginning value, we use the y value. So we would say our zeroth number is -7. Then for our rate of change, we have to look at how the x's are changing versus how the y's are changing. So when I look across the top, I see that my numbers are increasing by 1. And sometimes your tables will have the same rate of change the whole time. Sometimes they might skip around numbers, but you can use the change between any 2 points to find your overall rate of change. So up there, what we just found where I labeled, that's technically our change in x, our delta x, if you will. Then I look at my y values. So in my y values, I'm increasing by 4, and I can see each time I'm increasing by 4, and that number represents my change or my delta y. So remember, rate of change, we say the change in y over the change in x. So my y was changing by 4 while my x was changing by 1, and then I can simplify that. 4 divided by 1 is just 4. So then those are the two pieces we need to write our equation. We write our equation as y equals 4x minus 7. And I'm using that minus sign because my zeroth number was a -7. So the minus takes care of that. This equation gives us something that would help us find any point in our table. And so in example 4, it asks us to find y when x is 15. So I had my equation was y equals 4x minus 7, and I was given that x is 15. So I'm going to replace the x with 15 in my equation because that's the number that I know. So replace that x with a 15, and when I do that, I'm going to put parentheses around it because I'm substituting, and then keep that minus 7. And from here, we can just simplify. 4 times 15 is 60. You're welcome to use a calculator if you need it. And then 60 minus 7 is 53. So if I kept my table going for a while, when x is 15, y would be 53. So now, if you think this is kind of making sense to you, feel free to pause and try the next one by yourself and then check it with the video. If you think you need one more example, just keep on going with me. So in this example, we've got to do the exact same thing. So pause your video, write your table down if you didn't print out the notes. But we're asked for the zeroth term. So notice when I'm looking in my table, there's nowhere where x is 0. but we can figure out what it should be. So just like when we were doing sequences and we had to find the 0th term, we can do the same thing, and I'm just going to write that over here. So I'm going to add in a little 0 column for myself, and I'm going to have to figure out my pattern a little earlier this time. So as we move down our table, when our x changes by 1, as we increase each x by 1, I can tell that I am decreasing by, looks like 2.5. So our numbers are dropping by 2.5 in the y for every increase of 1 in the x. So just like before when we would have to find the 0 term, we work backwards. And to find the 0 term, I would take 29.5, that's my first term, and add 2.5. And that would give me 32. So my 0 term is 32, and I had to actually find that myself this time, but that's the number that I want to use for my 0th number in my equation. And then we've started finding our rate of change. Remember, for rate of change, we use the change in y over the change in x. So my change in y, I'm going down 2.5 for every increase of 1 in my x. So that, when I simplify, negative 2.5 divided by 1 is negative 2.5. If you do this with fractions, you are welcome to leave your answers fractions. Fractions or decimals are fine for rate of change. So then my equation is going to be y equals negative 2.5 x, and then my 0th term was a positive 32, so I'm going to put plus 32 on this one. And then again, I'm just asked to use my equation. So I'm told that when x is 8, I want to find what y should be. So I'm going to use my equation, y equals negative 2.5 x plus 32. And I'm going to replace in my equation the x with an 8. And again, I'm specifically picking the x because that was the information I was given. I was told that x is 8, so I have to replace that variable. So y equals negative 2.5 times 8 plus 32. And then from here, we are just doing those calculations. So feel free to use a calculator if you need to. If you do negative 2.5 times 8, that will be 20, negative 20, because it was a negative 2.5, plus 32. Negative 20 plus 32 is positive 12. So this is how we can use tables to write linear equations, just like the previous lesson we were using graphs. One thing worth mentioning is that, again, sometimes your x values won't always just increase by 1. These two examples did, but we will look at some point that don't just increase by 1, where you do have to pay a little bit more attention. Your rate of change may not just be the same as the way you're changing in y.